Here we'll find the surface areas of different prisms. But before we get into what surface area is, take a look at this cube here. Suppose the side length of this cube is S. First, what's the area of this yellow face of the cube, which is a square with side length S? If you're not sure, click down here to review. Right, the area of this square face is S times S, and we can write S times S as S squared. So that's the area of one face of our cube. Now the surface area of a solid is the total area of its outer surface. One way to see the surface area of this cube is to unfold it. When you unfold a solid into a flat shape like this, the result is called a net. From this net of our cube, you can see that it has 6 square faces, and each of those faces has an area of S squared. Let's just refold this net back into a cube. So with its 6 faces, what's the surface area of this cube in terms of S? Exactly. The surface area of this cube is S squared, the area of one of the faces, times 6, the total number of faces. Now here's another cube, and suppose its side length is 3. What's the surface area of this cube? Nicely done. Now let's go from cubes to rectangular prisms, like this one. Suppose this rectangular prism has a height of A, a width of B, and a depth of C. In terms of A, B, and C, what's the surface area of this prism? This is pretty tricky, so if you're not sure, just click down here. Okay, no problem. Now the surface area of this prism is the sum of the areas of all its faces. So first, how many faces does this prism have? Let's give it another quick spin so you can see it from a few different angles. Exactly right. This prism has 6 faces. So let's start adding up the areas of those faces. And we'll begin with this rectangular face in the back. Notice that it has the same shape and size as this rectangular face in front. So in terms of A, B, and C, what's the area of these 2 faces? Right, this rectangular face has an area of A times B. And this face back here also has an area of A times B. So adding these 2 areas together, we have AB plus another AB, or 2AB. Next, let's look at this rectangular face over here, which is the same as this face over here. What's the area of these 2 faces? Nicely done. Each of these faces has an area of A times C, so together their combined area is 2AC. So far we've looked at 4 faces, which means we have 2 more to go. One of them is this rectangular face on the bottom of our prism, and the other is this face on top. What's the area of these 2 faces? Right, each of these faces has an area of BC, so together their combined area is 2BC. So here's the surface area of this rectangular prism, 2AB plus 2AC plus 2BC. Next, try finding the surface area of this prism over here. It has a height of 1, a length of 4, and a depth of 3. You can use this formula, or you can add up the areas of all the faces of this prism. Either way, you should get the same answer. Nicely done. So far, we've been looking at cubes and rectangular prisms. Next, let's look at a prism whose base is a triangle instead of a rectangle. Suppose this right triangle is the base of our prism, and that its legs have lengths 3 and 4, and its hypotenuse has length 5. First, what's the area of this triangle? Great! Now let's look at a triangular prism. As we already said, our right triangular base has side lengths of 3, 4, and 5. And now suppose the height of this triangular prism is also 5. What's the surface area of this prism? Rather than using a formula, try finding the areas of all the faces and then adding them up. Very well done. This face has an area of 15, this face has an area of 20, and the 5 by 5 square face in the back has an area of 25. And as you found earlier, the triangle on top has an area of 6, as does the triangular base. So adding up these areas, you found that the surface area of this triangular prism is 72. Let's finish this lesson with a final question to see how surface area matters. Here are 8 unit cubes, meaning they're cubes with side length 1. Now there are many ways we can arrange these 8 unit cubes. For example, we can line them up in a row. Another way to arrange them is to have 2 rows with 4 cubes in each row. And yet another way is to put these 4 cubes on top, making a larger cube. So looking at these 3 different arrangements, we have a prism with a length of 8 and a height and depth of 1, another prism that's 1 by 4 by 2, and a cube that's 2 by 2 by 2. And all of these are made up of 8 unit cubes. But it turns out that these 3 arrangements all have different surface areas. Which of these has the least surface area? Exactly. This prism has a surface area of 34, this one has a surface area of 28, and the cube over here has the least surface area of these 3 solids with a surface area of just 24. So why does this matter? Well, the more surface area a block of ice has, the more contact it has with its warmer environment, so the faster it'll melt. And that's why ice cubes are so common. For a given volume or amount of ice, ice cubes have less surface area, so they melt more slowly and last longer in your drink. Let's find the surface area of a few pyramids. But before we get started, which of these solids is a pyramid? If you're not sure, click down here to review. Great! Now let's find the surface area of this pyramid, meaning we'll be adding up the areas of all its faces. Suppose its base is a square with a side length of 6, and let's also say the vertical height of this pyramid is 4. Now one way to find the surface area of a solid is to unfold it into a flat shape. This flat, unfolded version of the solid is called a net. So if we add up the areas of all these shapes in the net, we'll have the surface area of our pyramid. Let's start with the square in the middle, which we said had a side length of 6. What's the area of this purple square? Exactly, this square has an area of 36. So next we should find the areas of these 4 surrounding triangles. They all have the same area, so let's just look at one of them, this triangle up here. We know it has a base of 6, but to find its area it would be great if we knew its height. Now to find the height of this triangle, let's fold the pyramid up again. Remember we said that the height of this pyramid is 4, but the height of our triangle is actually the length of this green line over here, which is also known as the slant height of the pyramid. Try using the Pythagorean theorem to find this pyramid's slant height. If you get stuck, just click over here. Exactly right. You found the slant height by looking at this right triangle inside the pyramid. This leg is the height of the pyramid, so it has length 4. And the length of this leg down here is half the length of one side of the square base, so it's 3. And that means the hypotenuse of this right triangle, which is the slant height of our pyramid, is 5. So now that we know the pyramid's slant height, what's the area of this triangular face, which has a base of 6 and a height of 5? Well done! So each of the triangular faces of this pyramid has an area of 15. So what's the total surface area of this right square pyramid? Remember to add up the areas of all 4 triangular faces as well as the square base. Well done! You found the area of this triangular face is 15, and there's a total of 4 triangular faces. And earlier, you found the square base has an area of 36. Adding all these areas together gave you a total surface area of 96. Let's try one final problem. Take a look at this right square pyramid here. Suppose its base has a side length of 10, and the vertical height of this pyramid is 12. What's the total surface area of this pyramid?